Well, hi, good morning. Thanks so much for joining me in my shop for day 2 on this radio. We're going to start changing out some capacitors on it. But first, I've got two really shocking facts. I believe this to be true. Facts about viruses, which I'm going to share with you, because both of these facts have really disturbed my view of almost everything. Here comes the first one. The first one. Now, how true is this? I believe it to be true, or I wouldn't repeat this here, but then you might want to look into this a little bit yourself to find out how true is this. If you could extract all the coronavirus from all the humans on Earth that have it in their systems right now, the billions and billions of virus particles that must exist all around the world, if you could vacuum them out and put them into one container, how big a container would you need to hold the world's stock of coronavirus? You know how big? About that big. It's just a little plastic cap, about this big. You fill this full of coronavirus, run out in my front yard, throw it up in the air, and eventually, well, you only need a couple viruses for that to work, but I just think about that. That's the amount of virus that's infecting the world. So I have a hard time believing that. Wow, what that says is virus particles are tiny. They are, well, they're pretty much at atomic scale, aren't they? I mean, they're among the smallest things in the world. Gone. Statistic number 2. So just how many virus particles are there in the world? So it turns out, if you compare the number of virus particles in the planet Earth to the number of stars in the universe, you have to multiply the number of stars by 100 million. Stars in the universe is a huge number. 100 million is a huge number. Multiply those together and you get the number of viruses on the planet. Isn't that number just stunning? It's stunning. I mean, it's 10 to the 31st. Somebody has estimated this. 10 to the 31st power. So the part that I find unsettling about this is, what kind of world am I living in? The fact is, we're coated with viruses, we're coated with bacteria, all this kind of stuff. Small things we can't see and never think about. We don't live in the world we think we live in. Thank God. If we could see viruses, I think we'd be freaked out. Freaked out all the time. Okay, so what capacitors are going to change here? I'm going to start with the audio section. That's these guys down here. I still don't have the schematic. I don't know what radio model I've got in front of me yet. Yesterday I took some voltage tests. I found what appeared to be a leak voltage, or a charge leaking through, I think it was this capacitor over to here. I'm going to repeat those tests, mark down the values, change the capacitors, repeat the test, and see if a change has occurred. That's what I'm going to do. And we'll test those capacitors in the meantime too. So I think there's 3 paper ones here. See, there's one already replaced back there. So I'll do these 3. I'm going to leave that electrolytic one there for now. And before that, off camera, I'll repeat those tests and make some notes, and next time you see it, the capacitors will be changed. Okay, 3 new capacitors in there, and only one of them actually showed any signs of a leak, and that's this one here, which is replaced here. That blue one there, you can see. So this is really the one that's of great interest. Now I numbered them 1, 2, and 3, so I wouldn't get them mixed up. So let's test number 1 here. There's number 1. The Stratfield Company, Bridgeport, Connecticut, made in the USA. Okay, now let's put it to the test. Now I haven't run the radio to find out if in fact that voltage, the little voltage develops on the wrong side of this capacitor, along the wrong side of the new one. So we don't know yet if what I measured was caused by a leak in this capacitor. So the first thing we're going to find out here is can it block 50 volts? Yeah, it says 25. It says 25 there, but it's really 50. There we go. Yes, it can. How about 150? No, the eye's not opening at 150. So this is kind of, you know, as capacitors go, I don't think it's not opening fully either here. It's leaky, but it's not as bad as many I have come across. So, but that's enough of a leak to probably justify the small charge I measured on it. Let's just test the other two. This one has 75 volts on one side and showed 0 on the other, but the other side could have been going to the chassis, so it's bound to show 0. A lot of these capacitors, and one side is on the chassis, so you always get a 0 there, of course. 50 volts, what do you say? Right open. 150? Open a little bit. So this guy appears to have been holding back his voltage, but like I said, if it's going to the chassis on the one side, then kind of the way I was testing it doesn't mean an awful lot. And now number 2 here. This guy was conveying the audio from the volume control over to the triode preamp. How's he stand up? This one's not under any kind of pressure. Well, that didn't open very well. Let's see, 150, no hope. So these are typical of capacitors from this day and age. Hang on there, Peanut. Okay, I hear you. Here's a brand new capacitor, just to compare. Yeah, I hear you, man. I hear you. I'm coming. Just to prove my machine. Okay, 150 volts. Right open. 350 volts. Right open. How about 450 volts? But you see, a new capacitor has essentially zero leakage through it. There we are. That's a charged up capacitor there. Now I must go and attend. Yes, who's that? Peanut? Peanut, are you out there? Silence. What's happening to him? Where'd he go? Oh, there he is. Come on. Come on. Okay, I'm going to come spend some time with you, okay? Yes, I'm going to go over there. Don't worry. That was his message right there. I've come to conclude that cats must think people are really stupid. Because what cats are doing, because they can't use words to communicate, they just use position and things like that, and then they leave it up to the other guy to figure it out. We look pretty stupid to them a lot of the time, because as far as they're concerned, we should figure it out. Look at the angry look on this cat's face here. Hey. You impatient? Let's go. There it is again. See? That is it. That's the communication that he wants to go. Spend some time with me. So talk to your cats. I'll be back in a bit. Okay, let's see if we've improved anything here. I don't really expect the radio to sound any better. There we go. Power on. So I made a few changes to capacitors, so I'm always switching the power on using the dim lights there. And boy, are they dim. Can't even see any light coming out of them. This radio is very slow to warm up. There's no B plus in the set until the rectifier warms up. It's very slow. Very slow. Oh, boy. I started having my doubts there. Tons of volume in this radio. Okay, so the one capacitor, we found 47 at one end and a little leak of 1 volt at the other. Let's see what we got now. Does this make any difference? So it was 47 up here. So we're reading 44 right now. Okay, and the other side, nothing, 0. Meter very sensitive, it's nothing. So that's an example of a capacitor leaking charge and having the charge build up on the far side of the capacitor. What exactly was this? Is this terminal here? Let's find out what it is, because I can't remember offhand. That tube, it's actually running really between two tubes here. So there's a rectifier tube, output tube, and the output tube was a 35L6. That's right, 35L6. 35L6. And the pin the capacitor is on is 1, 2, 3, 4, pin 5. Pin 5. Pin 5 is the grid. So there we are. So this is a grid blocking capacitor, and some of it was leaking over, causing this grid to go a little bit positive. Now this tube gets its bias from a cathode resistor, and it's got this electrolytic capacitor here I'm kind of curious about. Let's see if we can find out about that. So that capacitor, one side, the negative side's on the chassis, the other side's right here. What have we got for a voltage there? Not much. So we're seeing a positive voltage of 15, about 5 volts, which sounds like a bias voltage. But I'm sure it is a bias voltage. Somewhere there should be a cathode resistor. You know what? There's a cathode resistor way down under there. You can hardly see it. Down under this. So this looks like a recent addition. Would seem to be working fine. A little hard to tell offhand. I'm just going to leave that. I don't think there's any reason to change it. It doesn't look that old, and the one I put in there would look almost identical to it anyway. And that's pin 8. Pin 8. Yeah. Right on the cathode. Good. Okay. Next on the hit parade. Now what was this one? So someone else did this yellow one. That's off the rectifier. It's right off the power cord here. And it goes to ground. So this capacitor is going between the power supply and the chassis. And there's probably a resistor somewhere paralleling it in here. That's a critical capacitor, and good thing it's changed. I have no idea if it's the right size or not. So let's look at this big one next. So look at that. It's a big whopper. It's not part of the power supply. Not really. Its job is almost certainly to quiet down the screen circuits, to drain the screen circuits of any signal that might be on it. 0.25 is that's a large capacitor. Let's look at the voltage across it first. So it goes to this terminal. These wires are all connected together. There's a continuous, it's an unusual looking terminal. Not to earth or to chassis, but just straight across. So that's, look at the red. This has got to be B plus coming here. It's on the meter about 80 volts. So on this side of the capacitor there's 80 volts. And on the other side, I think that's going to a ground terminal up here. I think it's going there. I'm not going to see any voltage. So got the outside flow. So that makes perfect sense. It's a great big capacitor hooked up to, well, B plus maybe? I think that's got to be a screen lead there. Let's see if I can trace one wire. So there's a red wire that comes over to this spot here. Yep, there it is on the meter. So now what tube is that? And what pin is that? So that's pin number 1, 2, 3, 4, 5, 6. Pin 6. And what kind of tube is it? Pin 6. I'll have to go around this way. And the tube is a, make sure I'm looking at the right tube here. I could guess it, but can't see. How hot is it? It's hot. It's a hot tube. This one way to be sure. 12SK7. Okay, that's exactly what I thought it was. SK7. So the K7 is a typical amplifier for the IF. 12SSSS. SQ. There it is. Well, that's K7. Jim, what's going on with you here? Right in the middle of it. How do mistakes get made? Pin 5. Pin 5 is a cathode. It's not at all what I expected. I expected it to go to the screen, which would be pin 6. Pin 6. Pin 6 on this tube. Eight, 7, 6. It's pin 6. Not 5. So pin 6 is the screen. So this guy is connected to the screens, gliding the screens down. Now, if that's not working, what will happen is we will get a whine as you tune in stations. That's one thing that can happen. You'll always hear a heterodyne as you tune in something. Let's see if there's any of that in this radio at all. If I'll just try to tune something in here. Now there certainly is a whine in here. I think it's from noise, adjacent noise signals. Because what we're looking for is a beat frequency that will start high, come down, and go back up. Something like that as I tune through. I don't hear that. What I hear is a steady state tone, just from adjacent interference. Got that? Seems to sound a lot better. Okay, power off. So I'm going to go after this capacitor anyway. It does seem to be doing its job, as far as I can tell. The thing is, there's a couple of tubes in here have screens. They share the same screen supply. They will share any of the signals that are on the screens with each other, and that'll set up a feedback. This drains out those signals, and so you can afford to use the same supply. We'll test this one right away. This is a big honker. Looks to be in great shape. This is a Cornell Dubilier, whatever that is. Tiger. It's a tiger. Let's go see if it's a tiger. A tiger of a capacitor. This is a big one, so it takes a little longer to charge up. When I hit the switch here, the eye may close for a second or two while it's charging. What are we on here? We're on that. Ooh. Okay, 50 volts. What does it do? There, it's swinging open. So just as the listening to the radio suggested, this capacitor is probably doing its job. Has a small leak in it. Would the leak matter? I don't think so. I would be talking about leaking microamps off of a B+ that's got lots of oomph compared to microamps. So this is probably not dragging down the radio at all at this point. And looking at the quality of the capacitor, this is probably going to work for another, I don't know, another 50 years. And I've gone and cut it out. Poor guy, could have left them in there. 0.25. Okay, well, he's done like dinner now. And we will put in a 0.25. Oops, that's not 0.25. Okay, let me put in the capacitor and we'll get it done. Okay, got the capacitor in there. Let's give this guy another test. I don't think we'll notice any difference whatsoever with this. I guess there's a lot of cases where you can have a capacitor with a bit of a leak through it. It's just not going to have any bearing on the operation of the radio, provided it's a relatively minor leak, which I think they all are. I mean, obviously if you have a shorted capacitor, that's a different deal. Here I am again. Patience. There it comes. Hear the same squeal there, but the tone doesn't vary when I tune the pitch. So it's not a heterodyne through there. It sounds the same otherwise. Not surprising. Okay, but always good to discover the radio is still working after you do some work. What's left now? So now we have this one in terms of paper capacitors, and you know what? That might be the end of it. No, there's another one. There's another one hidden back here. Going to the tone. This is the tone controller. I may leave that. I'm not even sure I tested that one for potential across it, but I don't think there's any potential across it. You know what? It depends where the tone control is located in the circuit. Let's give it a check. I'll put the power back on. See, from where I've been standing, see, it's like the pilot looking out his windshield and he can't see the oncoming plane because there's a windshield bar in the way. He can't see it until, oh, it's too late, and the plane crashes. That happened. Okay. Now, this capacitor. Okay, and the meter. See anything? I don't see anything there at all. Let's just check my meter again. Onto the B+ here. Not quite 70. Not quite 70. That's ground. Okay, so this is the capacitor in question. One side has 45 volts on it, and the other side shows a 0, which is good. So it's probably holding it back just fine. It can be that it depends what's going on this side of the capacitor. If it's a low impedance circuit, then whatever charge leaks through, tiny charge leaks through, it'll just be lost in whatever. It can't build up. If this is a high impedance circuit, let's see. So this wire is going to the chassis. So one side of this control is going to the chassis. So it would depend upon where this is the tone control. Oh my gosh, it sure works, eh? So let's think about this now. Right now I have a short, because of the setting of this control, I have a short on this side of the capacitor. So I'm going to put in the resistance now. Turn down the radio a bit. Give it a moment. Do we get anything showing up now? Oh, look at that. So if I increase the resistance here, it's going to knock this down. Yeah. So what that's showing is there is a charge leaking through this capacitor from the high side here towards the low side, but when the resistor here is set low, the charge just goes right into the chassis. Turn up the resistor, it build up the charge on this side, until the rate of charge dissipation on this side of the capacitor equals the rate of charge flow through the capacitor. Then you get a nice stable voltage. Okay, we got to change that one. That's another one leaking right into the tone control. Now, would this cause some kind of disastrous result in the radio? I don't think so. But puts just a little more strain on the B plus because there's a few micros heading for it. Let's cut it right off at the terminals, this bottom terminal. It's the bottom terminal, but for all I know, I'm going to be distracted and be out of here for half an hour, so I'm going to do that. So at any moment I can get distracted away from here. Ooh. Paper capacitor. Uh-oh. So this is very similar to some others, so I can probably guess at that it's a 0.005. There it is, I see it. 005, just remnants of it. Okay, so we'll put a 0.005 in there. We'll see what happens then. Okay, time for another attempt here. Let's get the radio going. Why don't we test this guy while the radio's warming up? Hey, now that would be efficient, wouldn't it? So this one appears to leak in the radio. 50 volts, here we go. Right open, 150. Wow, this is better than the others. 250. Still opening, so wow. Okay, so not much of a leak in this one yet. Voltage showing up on the other side. Now, is that because my test was actually kind of a bogus thing I did? Let's test this one. So the new capacitor's in there. The radio's on, Jen. Watch your fingers. Watch your fingers. There we are. There's a lot of volume in this radio. At least the volume action's early on the control. Yeah, lots of volume. Chuk, 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 chuk. My soldering iron. Get rid of that. Okay, voltage test. This side. Oops, whoop, 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 whoop. This side. So that's 44 volts. And on the other side, now I change the tone control here. Oh, I'm missing all the excitement. Volume down. On the supply side of the capacitor, if I can call it that, that's 45 volts on the meter. On the other side, nothing. 1.5 volt full scale. Looks like it moves the meter a tiny amount. Who knows what that is? There we go. So I stopped a little leak there. Improved the radio. What's happened? Oh, you know what I think I've done? I think I put in a 0.05 instead of a 0.005. No, I didn't do that. What happened there? 0.005. I got some wrong capacitors in here. .0047. That's 0.005. Maybe I've got some. Once in a while, you know, I put the wrong capacitors in my drawers. 0.0047. It's working like a volume control now. Oh, maybe not. Just I guess all the program material is high frequency noise, so with the volume set low. Yeah, that's fine. That's fine. That's good. Okay. Could chase ghosts here. Great. So we're good to hear now. Now what are we left with? Now I think we're left with, and I look carefully, one here. It's a capacitor to ground. Did I turn the radio back on? Let's test the voltage across there. I don't think there would be anything up here. Well, let's take a look. Okay. I don't think there's any voltage up here. Well, there's a little something going on. Okay, so upscale is negative now. So it went up and then it starts dropping back. A little hard to see from your distant view of the meter, but now if I take this off, wait a little bit and then put it back on, does it do the same thing? It went up and then dropped back. I think if I leave it there long enough, there'll be a higher voltage on this end. Well, wait a second now. Why would that matter? The other end is grounded. If it's leaking, it pulls this voltage down. If there even should be one there, and there probably. There could be a bias voltage sitting there. So what am I getting out of this? What am I getting out of this? I'm not getting... It's curious. Maybe a small voltage building up on a fairly good capacitor and I'm bleeding it off with the voltmeter when I go like that. A small unimportant voltage. He says, I'm just guessing at this. No schematic to refer to. So we're going to get this guy out of here and put a shiny new one in there. .01. Okay, I'll get that installed. Oh, wait a minute. Let's give him a test here. Hold on. Let's give him a test. This thing's all waiting. Volts. It just barely opened. It looks like it didn't open on your camera, but it pretty much did not open. So this guy's a little more leaky than the other. Is it important here? You know, it might be, because it could be in very high impedance circuits, and there's no business having a resistor there, and it's possible. 0.01. Okay, I'm going to change it now. Okay, well, we're ready for another try here. Power on. Can't imagine that's going to make much difference to the sound of this radio. I think the radio is performing quite well already. And what's really due now will be an alignment, and I still don't even know the make or model number of this radio. But I'm sure to find out today. So tomorrow what'll be on deck for this guy is an alignment. Let me just turn off that. Volume seems... well, maybe not. Maybe it's just where it's tuned right now. Seems very different. See if we can pick something up here.
Perspective on the Steelers. Oh, no question. We were talking earlier this week. It is an AFC situation, as you point out, is the 40.
Well, you're lucky. If you try tuning that station here, you can't find it. It's over here.
Similar situation in college football.
Wow.
Last week, Kentucky was without about 16. Alabama. They still play.
So that's a Sports Channel 590. Where'd it go? Where'd you go, man?
Whether a game is pushed back or not, you start talking about
590.
Better off. And with your doctor's consent, advice,
640.
recommendations, and guidance, you can go back to work. You should go back to work. So no, once you get CPP disability, it does. Strong partnership brings innovation to life and invites you to experience
This station here can separate the men from the boys in my shop here. This is a AM station broadcasting out of Toronto. Popular one, 680 news channel. I hate listening to it myself, but that's what it is. And the thing is, there's a noise signal here at my house, right adjacent to it, maybe 3 kilohertz off from the carrier of that station, maybe a little higher. So a lot of radios, they cannot separate the station from the noise. You get both when you tune them in. Listen to this one. That's the noise. And there's the station. Okay, so it's not the greatest thing in the world, but how about like that? That's fantastic, actually. Let's try for a French station somewhere up in this area. See if we can get it. So a lot of radios struggle picking up this station in my shop, but not this one. Fantastic. Okay, that's just great. Boy, I tell you, I wish all radios went this way when I worked on them. If you watch all my videos, you know I was working on a great big Westinghouse, which I set aside for now, because it just didn't go this way. So alignment tomorrow. And I think this guy will be done. nice sound. I'll make a couple of repairs on the speaker tears. That's it. Thanks a lot for watching. And I'll see you tomorrow. You'll see me. Actually, you never do see me, do you?